Hello everyone, welcome to UNC virtual class, and today's lectures I am going to discuss one of very important fact of the ARM processor field, that's sure ARM floating point architectures. Here is the table of contents which I will discuss on today's class. First I will discuss introduction concept about the floating points. After that I will discuss the floating point architectures by using one hardware concept, that's sure FPA10 data types. Okay, so now to start our initial concept, that's sure introduction about the floating point architectures. First I will discuss about ARM floating point architectures. So as you know, on previous lectures already we viewed that the floating point concept to be normally used when any large integer value that to be built up by consisting multiple number of digital value, how this large integer value to be represented on reduced format, so that we have used the concept of floating points. Okay, but initially whenever the ARM processor to be designed, the ARM processor cannot be supported the floating point data manipulations. After that, another one concept architectures that to be embedding with the given ARM processor, so that any types of floating data manipulations to be possible. So what is the concept? That's your co-processor concept. That means by using your co-processor concept, the ARM processor to be executes any types of arithmetical calculations by acquiring the floating data elements. Okay, so now the question arises, how the floating point data elements to be executed in between your ARM processor through the help of co-processor. Initially that to be goes in 4 criteria whenever that to be executes with the help of co-processor. First, the co-processor to be executed any types of floating data value by consisting 2 co-processor data elements, that's your co-processor 1 and another one is the co-processor 2. Okay, and the second constraint, when we have to execute any types of floating data value, the data value size that to be 80 bit. That means the length should be 80 bit or maybe less than to 80 bit, but that cannot be larger than 80 bits. Okay, and the third concept, another one constraint that's to be provided, that's your APSR. That means floating point status registers. Here the floating point status registers to be used for providing all over the internal data processing operation status informations and also handling all over the error to be occurs on the intermediate data executions. Okay, and another last one constraint that to be provides, that's your APCR. That means floating point control registers that to be invisible, but the floating point status register that to be visible by the users. But when the floating point control registers that to be used, which is to be invisibles, that to be generally used for embedding the interface in between your software to hardware. That means how the software hardware to be accelerated through the data executions. In this case we have used one type of constraint, that's your floating point control registers. Okay, by using these 4 conditions, all over the co-processors to be easily executed any types of floating data value in random ways. Okay, so now to check how the architectures to be implemented in case of ARM processors. Here the ARM floating point architectures provides extensive supports for the data types entirely in software or using a combined software hardware solution based around the FPA10 floating point accelerator. That means here one hardware concept that to be implemented, that's your FPA10 floating point accelerator, through which different types of floating data easily to be manipulated by using any types of given softwares. And another concept here, the ARM co-processor architectures allows the floating point emulator softwares to be used interchangeable within the combination of the FPA10 and the floating point oscillator support code or any hardware software combinations that support set of instructions. That means here the ARM processor provides one type of software, that's your floating point emulator, through which we have to changeable all over the floating point data manipulations from one hardware to another hardware. Then check how this FPAIO data types to be implemented in case of ARM processors, so that all over the floating data types to be executed. Here the FPAIO data types to be provides another facilities. As you know, initially the ARM processors to be execute any types of floating data elements through the help of coprocessor on the format of single precision or double precision format. But after that, if any user to be needs for executing any data that to be long than double precision, so how that to be executed? That to be very easily executed if we have to add another types of data types, that's your FPAI data types. And by using this data types, we have to execute any types of packet decimal numbers and also double precision format data, that's to be normal 80 bit in length. And also in this case, it to be provides to performing load and store architectures manipulations, to performing load and store multiple number of register data calculations through the help of floating data points. All over the different types of operation which is to be held in between a register to register or register to memory and vice versa. Here all over the functionality to be very easily possible through acquiring the floating data elements on consisting one hardware, that's your FPAIO data types. So now to check how this given data types to be implemented in case of the ARM processor floating point data manipulation. Here the ARM FPA10 hardware floating point accelerator supports single, double and extended double precision format, that's your packet decimal formats are supported only by the software. That means by using this given hardware, we have to implement multiple number of floating points, maybe that to be consisting single precision or maybe that to be consisting double precisions by through the help of exponential, or maybe that to be consisting all over the data elements on the format of packet decimals. Every types of data that to be executed in very convenient purpose from register to register and register to memory and vice versa, and that to be provides very accuracy flow of executions. The next concept, that's your load and store floating instructions. That means here the load and store architectures of the floating point concepts that to be provides how all over the data that to be executed from register to memory or memory to register. That means at the time of data executions, how that to be roll on in between a register to memory by acquiring the floating point data elements. In case of by adding of coprocessor FPA10 data types. So how that to be possible and what is the binary structures of the binary encoding structures of this given data type elements. So now to check the binary structure of the load and store floating point instructions in case of FPAI0 data types. Here it consisting of 8 floating point registers. The register specified filled the coprocessor data transfer instructions, and also it to be consisting of one spare bit which is to be used for the additional data size specifiers. Okay, that means here X is the data size which is to be defines the floating data elements on the integer part, and another one is the data size which is to be defined for the data elements after the decimal points. That means before the decimal points, what are the size that to be defined by the X, and what are the data size after the decimal points that to be indicated by the value of Y. Okay. And another thing that we provides here the FRD, that means here is the destination register points. That means at the time of data executions, whatever the data value that to be stored through the help of course, that we provide the desired outcomes, and this desired outcomes to be stored and register FRD. Okay. Then after the other field in the format which is to be provides like your P, U, Y, W, L. Here that to be provides one conditions whenever the data to be provides on the format of single precision, whenever the data to be provides double precision, whenever the data to be provides on the packet decimal format. In this case that to be provides. That means here the Y bit to be specifies the data to be provides on the format of single packet. Okay, U provides the data to be provides on the format of double precisions. P provides for the data to be executed on the format of packet decimal format. Okay, that means by using the 32 bit, here also the floating types of data elements to be executed in an accuracy way from register to memory and memory to registers. Okay, so that's your load and store floating instruction in case of FPIO data types. Okay, so now goes to our next concept, that's your load and store multiple floating points. In case of load and store multiple floating point concept means, as you know, if we have to needed for executing only one data at a time, that to be possible by using your single registers, and also if the user to be need for executing multiple number of data value at a time through the help of multiple registers, that should be also possible. Similarly, at the time of data floating point calculations, if the user to be needs for executing multiple number of floating data value elements, here also the coprocessor to be provides same registers locations for the multiple data offloading for its executions. That means here the coprocessor also to be supports multiple number of registers at a time to be accepting all over the data value and different ways, and that to be performing one calculations on the desired time. Okay, so that's the concept of load and store multiple floating point elements. So here is the binary encoding structure of the load and store multiple floating point architectures. Okay, here the load and store floating registers instructions are used to save and restore the floating point register state. Each register is saved using 3 memory words like that's your 3 elements 1, 1, 0. That means that's your 3 memory words through which that to be checked. Here you have to execute multiple number of floating data value. Okay, and also in this case it is intended that the only use for the saved value will be reload them using the equivalent load multiple instruction to store the content, and the FRD specifies the first register to be transferred, and here X and Y encode the number of register transferred can be from 1 to 4. That means here X and Y to be specified. You have to transferring some data from register to memory and memory to register for performing any types of floating calculations. Okay, and after that here the coprocessor number 1 and coprocessor number 2 that to be specifies the register offset locations. That means as here it to be provides multiple number of data executions simultaneously, so that here the 8-bit offset provides dynamical data loading in case of load and store multiple floating point manipulations. Okay, so now goes to our next concept, that's your floating point data operations. Here the floating point data operations also to be requires 3 address field instruction execution as similar as ARM processor. That means as you know, in case of ARM processor it to be supports 3 address field for every types of arithmetical calculations. That means 2 address for the operands and 1 address for the resultant outcomes. Similarly, in case of floating point data operations, it to be requires 3 address. That means 2 for operands and 1 for the resultant outcomes. But when any types of data value that to be executed in case of floating data manipulations, in this case it to be first accepted all over the data value from ARM processor to coprocessors on the format of integers. After that, when the coprocessor to be receives the integer value and another one data type concept through the help of FPAI0 hardware, then it to be added the after decimal points data value. After that, it will be performing the data manipulations and stored into a registers for the future reference. And what in this case, if the ARM processor to be necessary for fetching this given resultant outcomes, in this case the coprocessor to be provides only the integral part. That means the integer value from coprocessor to ARM processors. Okay. So now to check the binary encoding structures in case of floating point data operations. Okay. Here the floating point data operation perform arithmetic functions on values through the floating point registers. Their only interaction with the outside world is to confirm that they should complete through the ARM coprocessor handshake, and also that we confirms how all over the instructions that to be executed by using its opcode instructions with augmented by extra bit from each of the 3 register specifier field, so that only 3 bits are required to specify one of the 8-bit floating point architectures. That means here the I bits to be specified select between a registers FRM or one of 8 constant for the second operand. Okay. E and COP2 here controls the destination size and rounding modes, and the J selects between the monadic and dyadic operations. That means whenever 2 types of operand we have to execute it, that times that to be selected, and also 3 types of operand whenever we have to execute it, that to be also selected. Okay. So now goes to our next concept, that's your floating point registers transfer. Floating point register transformation means whenever we have to need for performing the data processing instruction executions in case of ARM processor, we will very well know that in this case the register only held on in between a given processor for its executions. Similarly, in case of floating point register manipulations, here also all over the data that to be executed in between a register to registers. After that to be transforming all over the data from coprocessor to ARM processor through the help of registers. Why? Because the ARM processor only to be supports the integral data calculations, as it cannot be directly supports the floating point data manipulations. So first here the coprocessor to be performing their calculations properly, then after it to be stored the resultant on a given registers. After that, through the help of these registers, that to be transforming the data from coprocessor to ARM processors. Then after the ARM processor to be viewing the desired outcomes on the above output screens. Okay. So here is the binary encoding structures of the floating point register transformation. In this case, the registers transfer instructions accept a value from the return value of an ARM registers. This is generally combined with the floating point processing functions. Okay. Here the transfer from ARM to the floating point unit include float, through which it will convert integer to real floating point from ARM to coprocessors, and rise to the floating point status and control registers. After that, it will be fixed how the control registers to be provides the desired outcomes in appropriate way by using certain conditions. As we know, in case of ARM processors, when that to be executed, it will be provides 4 flags. In case of current program status registers like your NCVR. Similarly, in this case, when all of the data that to be held from register to registers, it will be also provides 4 flags informations. These 4 flags, that's your NZCV. Here N indicates less than and Z indicates equality, and C and V indicates more complex conditions including unordered comparisons result when the resultant outcomes to be provides NaN, that means not a numbers. In this case, it to be provide these 4 constraints at the time of data executions. Okay. So now goes to our next concept, that's your floating point instruction frequency. Here the floating point instruction frequency to be specified in which way all over the data that to be executed. That means what are the impact when the data to be held from one to other locations, what are the strength of the given of course. Here it will be provides different types of instructions for performing any types of floating point data manipulation. The instructions like your load and store, add, multiply, compare, fix and float, divide and others. So in this case, which instructions to be executes and that to be provides the accuracy outcomes without any error prone code. That means what are the frequency value in case of code executions and procedures. When we have to use the instruction load and store, here the frequency level value that's your 67%. And when we have used the add, of course, in this case that to be provides 13% frequency. And when we have to use multiply instruction, of course, in this case that to be occupies 10.5%. And after that, when we have to use any types of comparisons by using 2 operands, here that to be used 3%. And after that, it to be used another types of instructions as all over the data here converting from floating to integer at the time of data transformation from coprocessor to ARM processor. So in this case, fix and float of code to be provides frequency levels that show 2%, and the divide of course to be provides 1.5%, and the other instruction of course whenever we have to execute in case of floating points, here is the frequency levels that show 3%. That means in case of floating point data manipulation, here the FPAI0 is guided by the typical frequency of the various floating point instructions. These are measured by the program compilation time. How much time that to be required for the floating point data manipulation by whole different types of code instructions. So now goes to our next concept, that's your FPA10 pipelines. As you know, the pipelining concept to be used for executing multiple number of statements simultaneously by overlapping each others. That means by executing all over the data elements by acquiring as the one of operand for the previous desired outcomes in sequence manner. In this case, we have used the pipelining concept. Okay. Similarly, the FPA10 data types that we also use pipelining concept for executing floating point data manipulations. That means if we have to need for performing any types of job executions simultaneously by a whole multiple number of opcodes like your add, multiply or divides, in this case it to be used some precedence rules through which one after another instructions to be executed in an accuracy format. Similarly, in case of ARM processor also that to be provide some pipelining concept, how the multiple data to be executed on independent way. That means in this case that to be provides three-stage pipelining concept and also 5-stage pipelining concept. How all over the data that to be executed sequentially one after another in parallel way without affecting the previous job executions. Similarly, in this case, it also follows 3 pipelining concept. Here is the 3 pipelining concepts. That's your prefer, align, operand. That means first we have to aligning. That means first we have to check how many data values that should be required for presenting on the after decimal points, and also how many integer value we have to require for presenting on the left side, means integer part. That means we have to normalize the given normal data operand value. After that it goes to the calculate. That means now after collecting all over the operand, we have to performing the instruction calculations like your addition, multiplications or divisions as the opcodes to be provides. After that goes to next step, align. Align means normalized result. As we know, when floating points data we have to manipulate it, in this case it to be provides how we have to finding one normalized data value. That means one accuracy data value by using some protocols. That's your normal. There is no duplications to be occurs. Then lastly, it will be provides another types of pipelining stage. That's your round. That means apply appropriate rounding to the result. That means when we have to require for data transmitting from coprocessor to ARM processor, in this case we have to rounding from floating to integer data value. But if another user to be needs for rounding the 4-point data value on the 2-point data value format, that to be also possible in case of round. So by using your pipelining concept, 4-stage pipelining concept, all over the floating data manipulations to be very easily executed in case of ARM processor through the help of coprocessor. Okay. So in today's class we will discuss why you have used the floating point data manipulations and how the floating points to be calculated internally in between your ARM processors. In general way, the floating points to be used for representing all over the large integer value on the small part, on the small weights, and also we have to learn how the data to be executed by using your 4-stage pipelining concept in an accuracy format through the help of coprocessor 1 and coprocessor 2 instruction from same logical and physical register locations. And another concept we have to also learn how the data to be executed in between your from register to memory and memory to register through the concept of load and store architectures. Okay. So for today's class, that's all. If any doubt or conflict in your mind, then you can ask me with the help of comment box. That's all. Thanking thou.